good day. I am Elmer's Astronomo and welcome to my vlog. So in today's video, I am going to show you or tell you more information about the mangroves and seagrasses. So right now, currently, we are here at Pangangan Island, which located in Calapira. And today, I'm gonna show you what our mangroves looks like and the seagrasses. So come with me and I'm gonna show you where's the mangrove. In mangroves, there are three types of mangroves, which are the white mangroves, the black mangroves, and the red mangroves. So basically, the one you see there is the red mangroves. Why? Because as you can see, red mangroves grow in the edge of the shoreline, which is here. As you can see, this is the edge of the shoreline. So the red mangroves grows here. So in Pangangan Island, red mangroves are more abundant than the two mangrove types. So along the mangroves here, you can also see that there are varieties. I mean, a lot of seagrasses here. Also, there are a lot of seagrasses here, and also if you walk there, since it is kinda high tide, not that low tide. If it's too low tide, we can see more seagrasses there. But since the water is kinda high, we can see it.
Mangroves are a type of coastal and estuarine wetland that grows along the coast in tropical or subtropical latitudes around the world and is distinguished by the presence of salt-adapted trees and shrubs. Many mangrove forests are distinguished by a dense tangle or prop roots that gives the trees the appearance of standing on stilts above the water. This root system frequently serve to support the trees as well as provide a means of getting air to the roots while they are submerged during high tidal events in some species. Mangroves are woody plants that grow at the land-sea interface in tropical and subtropical latitudes, where they face high salinity, extreme tides, strong winds, high temperatures, and muddy and aerobic soils. There may be no other group of plants with such advanced morphological and psychological adaptation to harsh environments. Because of their environment, mangroves must be salt-tolerant and have mechanisms to take up water despite high osmotic potentials. Some absorb salt as well but excrete them via specialized glands in the leaves. Others store salts in senescent leaves or in the bark or wood of trees. Others simply become more conservative in their water use as the salinity of the water increases. Morphological specialization include profuse lateral roots that anchor the trees in the loose sediments, exposed aerial roots for gas exchange, and viviparous water-dispersed propagules. Seagrasses, on the other hand, are aquatic plants that evolved from terrestrial plants. They have leaves, flowers, seeds, roots, and connective tissues just like terrestrial plants. And they get their food from photosynthesis. Unlike terrestrial plants, however, they lack strong stems and rely on the buoyancy of the surrounding water to support themselves. Seagrasses provide an important food source and habitat for a diverse community of organisms such as fish, octopus, sea turtles, shrimp, blue crabs, oysters, sponges, sea urchins, anemones, clams, and squid. Seagrasses have been called the lungs of the sea because they release oxygen into the water through the process of photosynthesis. Seagrasses grow by extending horizontal rhizomes that produce vertical leaves and absorptive roots on a regular basis. The roots of seagrass consolidate and stabilize the sediment. The depth to which light can penetrate for photosynthesis is limited to a maximum of 200 meters for seagrass. The problem is leaving anoxic sediment is mitigated by oxygen conductance through erythema. Salt can be excluded or tolerated by seagrass tissues. The environment generally nutrient deficient. Nutrients can be obtained through both leaves and roots and are efficiently utilized. Despite the fact that seagrass can reproduce sexually and have evolved methods of aquatic pollination, so their propagation is vegetative. Seagrass have the ability to reproduce both sexually and asexually. They are seeds-producing flowering plants. To fertilize female flowers, pollen is carried through the water. Seagrass can also sprout new growth from rhizome roots, so a single plant can produce an entire underwater meadow. So, the main threats to seagrass meadows include urban, industrial, and agricultural runoff, coastal development, dredging, unregulated fishing and boating activities, and climate change. And mangroves, the single greatest threat to mangrove is coastal development. In addition to the direct impacts on mangrove forests from urbanizing coastal areas, such as wetland clearing and filling, coastal development alters the tide cycle through human-driven water management practices, such as mosquito ditching and dredging of coastal waterways. Changes in the flow of fresh water into mangrove system and the tidal regime have increased salinity and had an impact on the overall health of mangrove forest. The combination of these practices, as well as shoreline hardening and other coastal management efforts, has resulted in significant mangrove swamp loss. Seagrasses can assist us in addressing our most pressing environmental issues. They purify water, protect us from storms, feed hundreds of millions of people, support diverse biodiversity, and efficiently store carbon. We must make significant lifestyle changes to protect these endangered plant species. We can slow the rise in global temperatures by lowering our carbon footprint. Reduce your carbon footprint by eating less meat, taking alternative modes of transportation, buying used goods, and selecting a conservation-minded offsetting program. So, in protecting and conserving mangroves, there are many ways to do it. So, first is we recognize its significance. Second is we encourage the creation of mangrove conservation area. And the third is to spread the word about the value of mangroves. The fourth is to support resorts that value the mangrove system. And lastly, if there are any mangrove planting activities, we should consider volunteering them.
I got my head out the sunroof. I'm blasting